All right, let's get into it. We're always hearing about how AI is changing the world, right? But behind all that hype, there's a really disciplined engineering process. So today, we're going to put on our hard hats and walk through the actual blueprint that builders use to construct an AI system from the ground up.
So here's the big question we're tackling. How do you really go from just a simple idea to a powerful, working AI tool? I'll tell you right now, it's not magic. It is a structured, methodical life cycle. You should think of it less like some mysterious art form and more like building a skyscraper. Every single phase is absolutely critical. So, we're going to follow what I'm calling a builder's journey, and it's got 5 key stages. We'll start with the overall plan, the AI blueprint. Then we'll get into laying the foundation. After that, we'll see how we actually construct the AI engine. Then we'll release it into the wild. And finally, we'll talk about the constant guardians who protect it the whole time.
You know, any great construction project has to start with a plan. In the world of AI, trying to skip this step, that's like trying to build a skyscraper without a blueprint. It's not just a bad idea, it is a recipe for a very expensive, very public collapse. This is where the entire vision takes shape.
And that master plan, that whole process, is what we call the AI Development Lifecycle. It is the end-to-end professional standard. This is what separates a shaky little prototype from a secure, scalable AI solution that actually does what it's supposed to do.
Okay, now we get to the groundwork. And seriously, just like a skyscraper's foundation determines how strong it is and how high it can go, these first 3 phases are completely non-negotiable. Get these wrong, and the whole project is doomed.
This foundation is built on 3 huge pillars. First, you have to define the exact problem you're trying to solve. Second, you collect your raw materials, which, in this case, is data. And third, you have to prepare all that data for construction. If you get these 3 right, you are building on solid rock.
So, Phase 1, problem definition. This is where we ask all the tough questions right at the start. We're not just asking, hey, what are we building? We're asking, who are we building this for? How will we know if it's actually working? And most importantly, what are the ethical guardrails we need to build in from day one? Answering these questions now prevents some massive headaches later on.
So once we know what we're building, we need the materials to build it with. And for AI, that material is data. And this quote here really says it all. If the steel you're using to build your skyscraper is weak, the whole building's going to fail. It's the exact same idea here. That's why Phase 2, data collection, is all about getting high-quality, relevant data to fuel this thing.
But, raw materials are almost never ready to use right out of the box. So in Phase 3, data preparation, we have to clean and refine everything. This means getting rid of errors, kicking out duplicates, combining data from different places, and getting it all into a consistent format that our model can actually understand. This is the quality control that makes sure our foundation is totally sound. All right, our foundation is solid. Now it is time to start building upwards. We're finally constructing the core of our system, the AI engine itself. This is the fun part, where the model is actually designed, trained, and tested. This is where the intelligence gets built. And this construction process happens in 3 stages that kind of repeat. First, we design the model's architecture, the blueprint for the brain. Then, we train it using all that data we prepared. And finally, we evaluate its performance to see if it's any good. It's a cycle. You build, you test, you refine, and you do it again.
Model design. Think of this like choosing the right architectural plan for the job. You've got options. Do you need a simple structure, something like a decision tree, or are you building something way more complex, like a neural network? And this is also where security gets baked into the design itself, not bolted on at the end. It's like integrating the security system right into the building's framework from day one.
Okay, Phase 5 is training. This is basically the school time for our AI. We feed our prepared data to the model, and it starts to learn the patterns and the relationships hidden inside. It's constantly adjusting its own internal settings, trying to get better and better at making accurate predictions and minimizing its mistakes with every single pass.
So how do we know if all that training actually worked? Well, we test it. We give it a final exam using data it has never ever seen before. Accuracy is pretty simple. It's the overall grade. But sometimes you have to look closer. Let's say it's an AI for medical diagnosis. Precision tells us, of all the times the AI said this person is sick, how many were actually sick? You want high precision to avoid false alarms. But recall asks, of all the people who were actually sick, how many did our AI correctly identify? You'd want really high recall there, because you'd rather have a false alarm than miss a real disease. And if the scores aren't good enough, well, it's back to the training phase.
Okay, so our AI engine is built, it's tested, it passed its exams. But a building isn't very useful until people can actually go inside and use it, right? This next section is all about deployment, releasing our AI into the real world and making sure it stays on track.
Deployment is basically where the digital crane lifts our model into place. We have to decide where it's going to live, in the cloud, on a local server, maybe right on your phone. We use tools to package it up neatly so it runs the same way everywhere. And this is crucial. You always have a rollback plan, a big red button, just in case you need to pull it back for adjustments.
But once it's out there, the job is not done, because the real world changes. And this can cause a really interesting problem called model drift. This is when the model's accuracy starts to get worse over time, simply because the world it was trained on, well, that world doesn't really exist anymore. It's why a retail AI might keep recommending winter coats in July. You have to be constantly monitoring to catch this and keep the AI sharp.
And that brings us to our final section. Throughout this entire construction project, from the very first sketch on the blueprint to years after it's been deployed, there are these principles that act as constant guardians. These aren't just steps you check off a list, they are the fundamental building codes you have to follow at every single stage.
And this visual just lays it out so perfectly. Look at this. Security isn't just a final check you do at the door. And making sure the model is fair and ethical isn't something you do at the end. These are continuous, ongoing responsibilities that stretch across the entire life cycle, from the second you define the problem all the way through monitoring it out in the wild.
And really, that's the ultimate takeaway here. Building great AI is not a straight line. It's not a one-and-done kind of thing. As this quote nails, every single phase is connected. The results from your evaluation, they feed back into your training and design. What you learn from monitoring the model in the real world, that informs the next version you build. It's a continuous loop of improvement.
So, there you have it. A clear, structured blueprint for how to build robust, reliable AI systems. It's a powerful engineering discipline. But that leaves us with a final, and honestly, a much bigger question to think about. Now that we know how to build it, what should we be building with it?